Okay, everybody, so I wanted to talk about the last FRQ in the packet. Before we do so, I want you to know that part C of this, we're not going to talk about the local max and min part of it in this video because we will learn how to determine those things in Unit 4. So I just want to focus on part B and then part C of finding the second derivative. Now, again, part A you should do on your own. I would expect you to go ahead and do it. But part B, I'm going to do with you now. So we want to show that there's a point with x-coordinate 3 in which the line tangent to the curve is horizontal. So the first thing we need to know is there's a point with x-coordinate 3 on the curve. So what I want to do is find the y-coordinates for that. So I'm going to plug in 3 for the x. I'm going to simplify everything down. I'm going to get everything to the same side. And then I'm going to solve this for y. Now this happens to factor. I want two numbers that multiply to give me 8, add to give me negative 9. Those numbers would be negative 1 and negative 8. So I want a negative 2 here, and I want a negative 1 there. So my y values are going to be 1/4 and 2. So I want to show that there's a coordinate with x3 that the curve is horizontal. So one of these, if not both, will give me a 0 slope. So when I plug in 3, 1/4, this would be 3 times 1/4 minus 2 times 3. And I can already tell from looking at that before I even finish it that this is not going to give me a 0 slope because the number on top is not going to be 0. So this is not is not going to have a horizontal tangent line. So now I'm going to check 3, 2. See if the slope is 0 there. And this is looking more promising. I just need to finish it and make sure I'm not going to get 0 on the bottom, because 0 over 0 is not 0, it's undefined. And I think we're good. I think we're going to get 0 over 7. So there is a point that is on the curve and has a horizontal tangent line. Now, part C, again, just want to focus on getting the second derivative. So they gave you the first derivative in the problem. Oops, forgot the y. And now I'm going to take the derivative. So second derivative, I'm going to start with the quotient rule. Low, d high, minus high, d low, over low, low. Oof. And then I wouldn't want to leave the dy dx's in there. So I could substitute this thing in, but that's going to be kind of massive, right? So the idea is I want d squared y dx squared, so the second derivative, at the point found in part B, which that point was 3, 2. So what I'm going to do is, in this expression, I'm going to plug in 2 for all the y's and 3 for all the x's. Oh, running out of room. So what I've got here then is 16 minus 9, so that's 7, times 3 dy dx minus 2, minus 6 minus 6. That whole thing's going to be 0 over here. And all of that is over 16 minus 9, which is 7 squared, so 49. So now all I need to do to actually get the value of this is I need to know what dy dx is at this point as well. So to find that out, I'm going to plug 3 comma 2 into the actual derivative. But by the way, I don't even need to do the work for that, right? Because we found already that the slope there was 0. So dy dx there is 0. And so that slope is negative 14/49. It's the same thing as negative 2/7.